Okay, good afternoon, everyone. Today we have our acting director, Dr. Krishnan, here to introduce our eminent speaker, Dr. Professor Kamra. Sir, please.
Yeah. So good afternoon to everyone and welcome Professor Kamra Saab. It's a great honor to invite you to this lecture on cloud electrification, on the interaction of cloud electrification with its microphysics. And it's very nice to know that this is the 9th lecture of the cloud and precipitation physics and dynamics. And Professor Kamra, when looking at his credentials, is worked for almost more than 60 years of scientific research in this field, with a PhD degree in 1968 from the State University of Albany, and then he did his PhD. He worked at basically BSc and MSc degrees from Agra University, after which he joined the University of Roorkee, where he worked on atmospheric electricity in physics department under the supervision of NC Varshnaya. He obtained his PhD degree in 1968 and then left for postdoctoral research at the State University of New York in Albany. He worked with Professor Vonnegut. And then after returning to India, he joined the University of Roorkee as a pool officer and moved to IITM in 1974 as senior scientific officer, and then retired in 2006 as scientist G and presently emeritus scientist in IITM. So looking at his he has done a lot of work on in the field of atmospheric electricity, thunderstorm electrification, dust storm electrification, and aerosol physics. And so he has published more than 110 research articles. This is long back. This is as per the INSA report. Maybe it is updated now, and mentored a large number of PhD students. And his contributions are amazing. And he has been honored with the Young Scientist Award of the WMO in 1976, the Silver Jubilee Award of IITM 3 times, and is a fellow of the Indian Academy of Sciences, Bangalore, and the IMS, and also fellow of the INSA. And what is amazing with Professor Kamra is, even with this long experience, he still continues to work hard and do it with full enthusiasm and spirit, and that is very, very impressive. And I've always been impressed with his dedication and hard work and the curiosity to know things. And sir, it's really a great honor to have you give this important talk, and so it's really a great privilege for me to welcome you, sir. Thank you very much.
Thank you so
much.
And
you're a great inspiration. You are a great inspiration for all of us.
Thank you so much, Dr. Krishnan, for that very welcoming speech. And I would also request Dr. S.D. Pawar, who is having the significant association with Dr. Kamra, to say a few words about him.
Thank you, Dr. Tara. Good evening, everybody. Yeah, I am feeling very happy and privileged that I worked with Dr. Kamra more than 25 years. And his contribution, actually, when he was head of the division of instrumentation and observational technique division, he developed so many instruments to study the atmospheric electricity, and he established the atmospheric electricity observatory at IITM. Actually, such type of observatories are very rare. Hardly I can say 1 or 2 observatories are available all over the world. Then he developed a few laboratories, which is also very unique, actually, wind tunnel observatory or free fall tube observatory. That type of facilities are not available, it's only available in IITM, not only in India, but all over the world also. Such facilities are very rare, actually. It was really very enjoyable and a very good experience to work with him, and his dedication in science specifically is very great, actually. I really thank Dr. Kamra for his guidance and for our division.
Yeah.
Thank you.
Thank you, Dr. Pawar. And now let us all wholeheartedly welcome Dr. Kamra to give his lecture. Thank you so much, sir. Please. Yes, sir. We would like your presentation to be shared, please.
Is it visible?
Yes, sir. Thank you. You are audible also. Thank you.
Audible. Okay, thank you. So thank you, Dr. Krishnan and Dr. Pawar, for this very nice introduction. I don't know how much I deserve that, but it was a pleasure to be asked for this lecture today. So I will just speak something about the interactions of cloud electrification with its microphysics. What I plan to do is just to give a brief introduction of cloud electrical structure and what generates the electrical charges in that. And then we come to the main topic of the interactions of its electrification with how it affects the microphysics of clouds. So to start with, just to give a brief history, it was, as all of you may be knowing, this field started with the kite experiment, quite famous one by Benjamin Franklin in 1752. And although it was, he pointed out to be electrical in nature, but for almost a century and a half, there was no significant progress in this direction until Faraday's basic laws of electrostatics and Maxwell's equations of electromagnetic magnetism were given, and some new equipment and investigation techniques were introduced into this field, and that gave us quite knowledge about this topic. But in spite of all those developments, our understanding of cloud electrification till this date is not very satisfactory. Reason being that this whole phenomenon, if you consider of clouds getting electrified and producing lightning, it spans over 15 orders of magnitude, and the physics of all those processes are not very clear. So that is just, I think, I should say, status of this field. But needless to say that increasing amount of observational and modeling work and we are getting in this field, and now situation is much more improving. So to start with, if we consider a thundercloud and see its electrical structure, that is a cloud picture taken in New Mexico, and on that this imposition of dots to indicate its charge is imposed by Dr. Kribel. And as it is known by his observational and studies from satellites and surface observations and airborne observations, that upper part of the cloud has positive charge accumulated at about minus 40 degrees centigrade level. And the lower part of the cloud has negative charge at about minus 8 kilometer height from the surface. And this is what forms the main dipole, electrical dipole of the cloud. But below 0 degree centigrade or at about 0 degree centigrade, there is another charge pocket, positive charge pocket. And that may be small one or quite extensive. What we have noticed in tropical regions, it is quite large, and it exists for a long period of thunderstorm life. So that is just we can say instead of dipole, it's a tripole electrical structure of the thunderclouds that we have to deal with. Again, Kribel's observation from NASA's network of electric field mills, that they have a very dense network. It was observed that the lower negative charge is almost throughout the life of the thundercloud is almost fixed at fixed level, about 7 kilometers or so. But the upper positive charge keeps shifting upwards throughout the life. So that is very important observation from the point of view of studying the not only the electrical structure of the clouds, but also what generates these electrical charges. So, and other factor that electrical activity in cloud very much depends is on the height of the cloud top, or better, it is better related with the radar echo height of say 20 decibels or so. It is very much related, and as the cloud develops, the electrical activity in that increases with its vertical development. Another important observation is that, when you observe electric field at the surface of the earth, it is anti-fair weather, say positive electric field. But as soon as you get a shower, during that period, it turns to favor the polarity, indicating that the charge carried by precipitation is positive in nature. So, as just as to show the electrical structure, just in one, this is a vertical profile of inside which penetrates through the through the thunderstorm. So you get this polarity of electric field that changes at about minus 10 degrees centigrade, indicating presence of negative charge in the lower part of the cloud and positive charge in the upper part of the cloud. That is in a idealistic, in isolated thunder cloud, but clouds of more developed nature or mixed type of clouds, they widely differ. So when this charge separation has occurred, positive charge has deposited in the upper part, negative in the as soon as the electric field develops in that, and as soon as the electric field increases beyond breakdown value of the air, a lightning discharge occurs before the between the upper positive charge and lower negative charge. Or it may also occur from lower positive charge to Earth's surface, or even from negative charge to the Earth's surface. That is called cloud to ground discharge. These different levels are, of course, indicated for the charge carrying nature of the particles, but we will not go into that. So, what are the mechanisms that generate these charges? That is a primary question of electrification of clouds. And we have two types of mechanism, although there are more than half a dozen mechanisms, but they can be classified. One in precipitation mechanism, in which presence of precipitation is important to, it has to develop in a cloud before the electrical activity begins. And then convective mechanism, in which development of precipitation is not necessary, but the convective motions of the cloud, updraft and downdraft, they are responsible for its electrification. Just in brief, I will show that in inductive mechanism, what happens that larger precipitation particles, they have in a downward electric field, a negative charge induced on their top and hello, and positive induced charge on the bottom. So when small cloud drops collide with that, they carry positive charge upwards, and that whole large drops are charged positively. So under gravitational separation, the upper part of the cloud has positive charge and negative charge. In the similar thing, which is can happen in thunderclouds, are non-inductive mechanism, in which presence of electric field. Similarly, they are, but the mechanism responsible for that do not depend necessarily on the induced charges. But when smaller particles collide with that, there is some other mechanism which is responsible for the transfer of charge. And these charge transfers, they can, for them to occur, it is not necessary that the particles come into physical contact with each other, but charge transfer can occur by a spark, jumping spark. These are, I will not go into detail, but some domains which are still considered to be that depending upon the cloud water content and temperature, the vertical distribution, that that occurs in this second non-inductive charge mechanism, and it is almost agreed that is. But these are responsible. But one thing is still there is some different opinions about how the charge transferred. Incidentally, this mechanism also takes account of change of polarity. When the falling rain it comes down below 0 degree centigrade, the polarity of charge transfer reverses. The, so it may also be responsible for the lower positive charge pockets. This other convective mechanism was proposed long back, in which precipitation is not necessary, but what has been proposed that atmosphere as a whole, it has net positive space charge. So when a cloud develops with the updraft, it acquires a net positive charge. Then when it grows upwards, negative positive charge from the free atmosphere, it is attracted to that, and as soon as it enters the cloud, it is attached to cloud droplets. Yeah, mean free path may not be more than few tenths of meters. And at the boundaries, if with the downdraft, it is carried to the lower part of the cloud, and this thing goes on. By this mechanism, when electric field grows sufficiently, this positive charge of the atmosphere is not enough. So, but point discharge current starts at the ground from the sharp objects, and that produces a lot of charge, positive charge, and that is carried in the atmosphere. Then this bootstrap mechanism, as they say, it goes on, and electric field keeps developing. So that was, in short, what generates the electrical charges in the clouds. And now we come to the main topic of how this electrical activity in cloud affects the microphysics of the cloud. If we consider water drop, raindrop falling in free atmosphere, then it is what forces are acting on this are four forces. First is the surface tension. Surface tension force tries to keep it spherical in nature. Then hydrodynamic forces are there, aerodynamic forces are there, and then some forces due to the internal circulation of the raindrop, of the drop, which are introduced by acting those other forces. So as a result of all these forces, the drop changes its shape, but the surface tension force dominates when the other forces when drop is small. So droplets smaller than 1 millimeter diameter, they are almost spherical under the surface tension forces. But as the diameter exceeds this 1 millimeter dimension, then other forces dominate these the other forces, and it attains a kind of oblate shape. With the increasing size, it develops almost a flat shape with smooth curvature on its top. So this oblateness increases with the size of the drops, and other essential feature of these drops freely falling in atmosphere is that they oscillate. There are oscillations. Each raindrop drop, small or big, it is oscillating with with the frequency. And these frequencies, they oscillate because of several reasons have been proposed for that. This shedding of eddy, this forces, vortex eddies from the top of the water drop, turbulence of the atmosphere, or some collisions of small droplets with they can induce these forces. So as a result of these, all these things, all these forces, raindrops may break up or they change, they alter their shape. We have
Hello, sir. Sir, sorry to disturb. The slides are not moving, sir.
Is it?
Your slide is not moving to the next one. Sorry about that.
No, it is right from beginning or?
No. Only in the electrification and microphysics.
No, I have not changed.
Okay. Sorry.
This is the next one.
Okay. Yeah. Thank you.
No, I have kept speaking without this thing. So, this interaction of these electrical forces with these other forces, when it occurs, it adds another force which can distort the break up the water drop in the electric field. We have done some simulation experiments. Of course, there are a lot of theoretical and field studies done and to study this. How do they affect electric forces? Fact. So I will briefly discuss these results of these studies here. This wind tunnel, as all of you may be familiar, there is a blower that blows the air, and after entering a chamber, it is carried upwards with the honeycomb and screen to reduce the turbulence eddies and make it smoother. It enters this shape of this thing, and here there are two electrodes in this part where water drops of 2 to 8 or 10 millimeters can be suspended, and then there is one, sorry. And there is a back pressure plate which keeps the pressure velocity well stationary between the plates and allows the drop to oscillate in this part. So then you have a screen, different screens in which can create this velocity well. And this just to give a brief. So what happens in drop distortion? When you apply the vertical electric field, the drop because vertical electric field is the large-scale electric field in thunderclouds that has been observed, the particle tries to become more spherical. From its oblate shape, it becomes tries to becomes oblate, spherical, from oblate to spherical shape. And then if you apply horizontal electric field, it stretches the drop in horizontal direction, and drop becomes more oblate in this direction. So that is just some typical values of stretching of raindrop and making it more oblate or electrical, just to show how the we measured this distortion of the drops in terms of B by A. That is the usual practice ratio of minor to major excess of the raindrop. So as I said, it drop oscillates also. But if you increase the electric field, we have tried up to 500 kilovolts per meter. The frequency of the drops doesn't change much. It almost remains the same. It doesn't change with the variation of electric field. But surprisingly, it's the frequency of oscillation changes, and as you increase the electric field, it becomes more oblate in shape. As you might have heard that over the cities, big metropolitan cities, or over factories, industrial areas, or this thing, there are a lot of pollution that enters with convection into the cloud, and drops, raindrops are polluted. You sometimes have read in newspapers also that there is a white rain, this red rain, or even black rain. So how these air pollutants affect the shape of the drop, and how electric field changes its nature. We introduced some sulfate solution or nitrate solution into the distilled water, and we found that it reduces, it increases, it increases the oblateness distortion. Main factor being that adding this pollution to water reduces the surface tension force, which tries to keep it intact in spherical shape. So, there are implications for that. Because as they become more distorted, there is more transfer of electrical charge, and molecular discharges occurrence, flash rate also may also increase. Now, as I said, there are 4 forces acting on a falling on a drop: surface tension, aerodynamic, and internal internal forces due to drop circulation. In addition to that, if you apply electric field or charge carries some electric charge, there is another force, electrical force, that affects the shape of the drop. And that is another reason that can cause the breakup of the drop. So that is one experiment that is carried on in the same wind tunnel. that is suspended drop is photographed with the fast moving 1000 frames per second camera, and as the time electric field as the time increases with that oblate water drop uh, begins to ex, extend into a horizontal direction, and it becomes distorted. And sorry, and after some time it breaks up. Not only it breaks up, it ejects some small droplets at the both at the central bridge connecting these two large portions of the water drop, also and also at the edges of these small droplets. So that's how electrical forces. Another type of breakup that is observed in drops is this bag type of breakup, in which water drop keeps extending in horizontal direction. Most of the water drains down to its rim part because of gravity, and then it develops a canopy type of umbrella type of this action, and after some time that operates, and this type of breakup can introduce several tens of small droplets into the cloud. So this is quite important from the microphysical point of view, as I will discuss. Another interesting thing which we found was when water drop starts extending in horizontal direction, deforms in vertical direction, it breaks up after uh, some time, and this filament then squeezes into main body of the smaller droplet, and just because of momentum addition caused in this small droplet, it ejects a small droplet on the other side of the drop, as you can see here also in both cases. So that was a quite interesting observation, and no, as I tell, that all these things, drop diameter, and its breakup, extension of its dimension in horizontal direction, they are affected by the electric field. Where this electric field or drop may carry some electrical charge on that. So, as a some time back, we as it is generally it is done in terms of radioactivity half life. So if you take some number of drops at that, then half of them survive in after some time. So that we can call it half life of a drop. So that decreases when it is charged, and the amount of this thing depends upon the amount of charge it carries. As the charge increases, the distortion becomes more, half-life becomes less and less. Uh, Same thing happens in electric field. And as you can see, as the drop diameter increases, and the electric field in a fixed electric field, number of drop distortion increases, and surprisingly, even in 300 kilowatts per meter, which has been measured in thunderstorms, this kind of distortion can occur. That's just another demonstration of electric field in distorting the half-life of that. And what was surprisingly, usually the large-scale electric fields are vertical in direction, but there is a lot of observation that say that the horizontal electric field also exists, and quite surprisingly, the largest electric field, 3.4 kilowatts per centimeter, that has so far been measured in electric field was horizontal in direction. That was measured by firing a rocket and instrumented with the field mill. So Taylor Longback, in his instability criterion, he has treated the subject of effect of electric field on the shape of the drop. And in vertical electric field, he established a criterion that says that electric field can distort this raindrop, water drop, and its variation is like that. This. But what we found that when electric field is horizontal, the electric fields required to increase this distortion is about three times lower than that. And it is important observation that as we shall discuss, is an initiation of corona from water drops, and that can trigger a lightning. So regions of horizontal electrification may play a very important role in initiation of lightning discharge. That is the next one. Don't be scared by the word corona. It is not that one. It is the electrical discharge. So, yeah.
No, thank you.
It is first. These are first movie photographs taken with the movie camera when no electric field is applied and the drops are neutral. The drop breaks up in mostly in two. It's called dumbbell type of breakup. And usually only one drop is ejected from the bridge joining these two drops. But when it is placed in electric field, what happens that its elongation in horizontal direction is too much, and very interesting observation that we got that at some stage it emits a kind of discharge, what we call electrical streamers. There is a, I don't know whether you can see that in these photographs, but there is a spark type of thing originating at this in these photographs pointed by arrows. And that's again another photograph that is suspended in electric field. These are of course large drops, and electric fields are also high of 5 kilowatts per centimeter. But but it was difficult to capture these corona discharges. Luckily, it came in a few cases. So, just to increase the statistics, we what we did was that instead of photographing them, you observe static noise. You know, when suspended drop ejects one some corona discharge, electrical discharge, it gives a noise type of solution, noise, static noise at a medium wave or frequency. So we kept one radio at medium wave, tuned at a medium wave, and we quite a good number of cases we find that, and we found that the static noise increases with the electric field and with the drop or diameter. So there were, ejection of this corona discharge was not so rare to observe, but it in by photographic technique, we because it's say few milliseconds or 2 milliseconds, so in between the frames, there are these discharges make occur. So that we will not be able to record. But this type of technique was quite, and quite surprisingly, at electric field of 200 kilovolts, which is well within the limits of a large scale electric field. There are some cases which you found that in that also this corona occurs, and so probability of lightning being initiated by this process was quite strong. So just in a summary, what we want that what we can understand that if drop is spherical and it's located in a electric field, then distribution of lines of force will be that, because this is a conductor, so lines of force will be attracted towards that, and this is all right. But as the size of the drop increases, it becomes more oblate in shape. So keep changing this slide. So the amount of lines of force, number of lines of force, or you can say intensity of electric field that is induced on the surface of the drop is much higher on the horizontal ends of the drop, and as the drop increases its oblateness, this intensity of electric field keeps on increasing, and it stretches in horizontal direction. So this becomes when this shape of the drop becomes too much elongated that it cannot retain its horizontal long shape, then it finally it breaks up. And actually, if you just imagine that there is a kind of feedback mechanism between the shape of the drop, distortion of the drop, and electric field intensification. The more it distorts, the intensification of electric field becomes more. And more the electric field is concentrated, the more its elongation along the electric. So this thing goes on, and they feedback, these forces feedback each other, and that is why electric field becomes a very important factor in its breakup. Other thing, long back, I proposed, and that was quite well taken, was that as I mentioned in the beginning, uh, uh, induced charge mechanism to generate electric field, or non-inductive mechanism that generates that they charge the larger drops with the negative charge, and uh, uh, this smaller drops with the positive charge. Then under gravitational force, they separate from each other. But what I proposed was that no, this in if you don't take into account the electric field or electrical force acting on them, then this gravitational force is acting both acting downwards. But when electric force increases, then this electrical force tends to on the smaller drop in the downward direction, and that is in the upward direction. That means these electrical forces oppose the gravitational forces. So if the electrical force QE is increases to that level that it becomes it becomes equal to gravitational force, then their separation is not possible. So, and all those mechanisms are the separation of electrical charge is based on the separation of large particles from large particles under the force of gravity. So if you take into account the electrical force acting on them, then their separation is not possible. And if their separation is not possible, electric field will not grow beyond that limit. And I made small calculations with the first with the induced charge mechanism, and then with all other non-inductive mechanism. And what we found that the maximum electric field that you can grow by this type of mechanism is in the vicinity of maximum that you have observed. Now, just as a word of caution here, I can say that measurements of electric field so far is they have indicated that highest maximum electric field that has been measured is 3.4 kilovolts per meter. But if you want to bet with any atmospheric electrician, he will not bet on that. That fields much larger than that can there is a possibility that they can exist in that. If they exist in smaller regions in thunderclouds, that's another thing. And electrical charges on the drops also, they are of the order of Taylor's limit. And electrical forces acting on them may be so large that they limit the growth of electric field also. So this idea at that time was very much accepted, and if you see some papers in 70s, decade of 70s, they are all the major models were took account of it. They were revised and they agreed on that this effect of electrical forces. So here, what is of importance? If electrical forces acting on charge drops are so important in limiting the growth of electric field and limiting the velocity of that is a very that can be a very dominant factor in affecting the microphysics of the clouds. Not only that, I will not go into detail, but also in the dynamics of the clouds. Dynamics of the cloud, in short, I can say that you see uh, falling of the development of precipitation and falling of precipitation particles in it has been almost established that is the main mechanism of development of downdraft in a thunderstorm. So if this timing of this development of falling drop is altered by some mechanism, and there is a uh, limitation on that, then development of clouds in vertical direction that can be largely affected because at that time, you know, cloud is growing at the fastest rate in vertical direction. So, matter of only a few seconds also may matter in that direction. But so, coming to and I will say that all these factors that we have considered in with that, distortion of raindrops, distortion of their vertical terminal velocities, and their cross section, and their breakup and ejection of smaller drops due to breakup, they will dramatically change the collision coalescence mechanism, Langmuir chain reaction of the development of rain. And if they make it more narrower or more wider, then development of precipitation will be by this environment processes will be largely affected. Then, if these high electrical forces, they are important in small regions of the clouds, and they change the vertical velocity, terminal velocities of this, and drops, and these things, they may create some regions of inhomogeneities of both of cloud droplets and large raindrops also that may seriously affect. Another phenomenon which is I will say is one of the strongest supporter of this effect of electrical forces in clouds is a rain gush phenomenon. Now, those of you who are not familiar with this term, I'll just tell in a few sentences that if observe a lightning discharge directly over your head, I'm over the head in cloud, then after a few minutes you will experience large intensity of precipitation falling on the ground. That is observed in by many observers. But its more scientific method of observing this was with the radar, in which they observed that when lightning discharge occurs, along the channel, there is a development of large precipitation particles soon after mm, uh, few seconds of the occurrence of lightning. So what happens in that when a lightning discharge occurs, high temperatures of the channel, 2000 degrees centigrade or so higher than that, that produce a lot of ionization in the air. And this ions produced along that channel, soon they are collected by the cloud droplets. And collision and coalescence efficiencies of this these charge droplets will be so large that growth of precipitation particle will be very fast. And as soon as they grow up, precipitation particles, they start falling down. And a few minutes after that, you get a rain gush of several orders of magnitude greater than what is usual. This is the kind of well-established fact. Then another area, as I discussed, this initiation of lightning discharge. This although it is one of the possible mechanisms that has been suggested, the occurrence of corona at the ends of the large water suspended drops. That is one of these things. There are two things. One is the start of the discharge, and then occurrence of lightning. Now, this to trigger the lightning discharge. Initiation of lightning discharge requires a very high electric field. At Earth's surface, you have about 30 kilovolts per centimeter, that is breakdown of the air. But as you go higher up, pressure, atmospheric pressure decreases, and you get a medium of with the water drops, ice crystals, and this further reduces the electrical. So exact value is, I will say, is not known, but this is definitely very high value it requires. So to trigger a lightning discharge, even in small volumes, they can trigger it, and as electrical streamers, what we call, at the end of these large suspended drops. But this triggering requires high electric field, but it's propagation of these streamers which are responsible for the lightning discharge. They can propagate in much weaker electric field. So this triggering of lightning discharge may be one of the things, and that is a very dominant phenomenon.
Sir, 1 second. Actually, Professor Zev Levin is in the panel, and he like to say hello to you just before he leaves. Actually, he was here, and I invited him to interact with you because it was your great wish to meet him during the ICCP. So he would, Professor Zev Levin would like to speak with you right now.
Very pleasant. Dr. Kamra, I just wanted to say hi. And it's good to
hi. That's very nice of you to have spoken, and I am really moved by this gesture. And so, how are you doing these days?
I'm doing fine, considering all the virus that we have around. I guess I'm okay.
Well, that's pleasant. I was really expecting very much to see you and talk to you. very well remember our nice association and seeing you in one of the conference in Japan. That's
I hope in India pretty soon.
well. I will look forward to that. You must be preparing for next conference.
I'm not sure I am, but our age, you don't know if you can prepare anything like that, but I will try.
You look as young as you are.
Thank you very much. And Tara, thank you very much.
Learning. I have been learning.
Thank you so much, and we want to thank you and namaste to so that you came to meet our Kamra sir. This is really great. We are very thankful to you.
I even enjoyed the lecture, and I was happy. I was happy Dr. Kamra mentioned the Rengash because we did some work on that. And on the fall velocity of water drops. That's very nice. Thank you very much.
Yeah, we will soon be inviting you for a lecture also. Thank you so much.
Okay.
I know you have to leave now. So
I have to run because I have another appointment right now. In fact, I'm a little late. So be well and take care.
Thank you very much, and it's a really very happy surprise. Thank you very much.
I'm happy to surprise you. Okay, bye-bye.
Bye-bye.
Sir, please continue your lecture now. Sorry for the interruption.
That was an interesting interruption. Next thing, what I would like to talk, there are, Doppler radars. They have been now developed, and many meteorological agencies look forward to estimate precipitation on a much smaller scale in many large metropolitan cities, if they can be used on a very small, increased scales of both space and time at in particular regions of the cities. They can have this kind of forecast for that, and they can make an estimate of that. But electric field or electrical forces, on they put a limitation on that, as you might have heard. Both it's a distortion and breakup of the water drops, and terminal velocities of these drops, they are largely affected. They can be largely affected by the electrical forces acting on that. And as you know, the radar echo of Doppler radar, especially dual Doppler radar, with which these estimations are made, they can be this eco intensification may be much affected by the electrical forces. If one region have vertical electric field, one region has horizontal or no electric field, or this thing. So it's a kind of source of error in such estimation, because electric field monitoring of electric field in such thunderclouds is almost, I will not say being an optimistic person, it's not impossible task, but very difficult, beyond this our imagination. So if these things are they occur, this difference in eco intensity, they are definitely a source of error. Then another this electrical this ice crystals, what are being dipolar molecule. These small ice crystals are have a dipole type of electrical distribution, and when they are placed in large electric fields, they are oriented to in the direction of electric field. So if a lightning discharge occurs, suddenly electric field gets lower, and so orientation of these ice crystals may change, will change, and so there will be difference in optical properties of those regions of clouds. So these are few features which can have this thing, and there are a large number of phenomena in which there's such interactions in electrical and microphysics. They can affect their nature, and they can make a substantial change. I know the limitations of measuring of electrical parameters in clouds is a problematic area. So far, even basic measurements of electric field, it is not very satisfactory. Only some statistical things are known. So, but I think if we consider the rate of growth of electric field, which is almost exponential in thunderclouds, and large amount of charges that water drops can carry, is they indicate rather send a strong signal that such a mechanism should be such effects should be taken in different models and this thing. So that's all I have to say. Thank you very much for.
Thank you so much, sir, and for a nice talk. Sachin, are there questions from the audience?
No, at present there are no questions. We have posted the request in the chat box.
Okay.
Okay. Kamra sir, I have a question.
Yeah.
Okay. So you discuss about something about this wind tunnel experiment, where.
Hello, Sachin.
Just one.
Sachin, you are not audible. Sachin?
Yes.
Please talk.
Yes. Sir, you showed one slide regarding this wind tunnel experiment, and how the raindrops distorts under the fields of applied electric field. So with that experiment, is it possible to look the collisions, coalescence mechanism among the raindrops once they are break up?
Yeah, that can be seen. Actually, that's what study we have almost finished just now, or just at the back end of that. What we investigated so far was a spontaneous breakup of large drops that are more than 6.6 millimeter in diameter. But it is widely believed that now it's when smaller droplets, they collide with the large drop, then this collision may result in this kind of breakup. So with that, we have studied the problem of collision and coalescence, and then breakup of the drop with this collision mechanism, and we have got some interesting results. In that also, we found that electric field, definitely electrical forces, they are definitely important to consider. That's also, I can say, summary of that, but we'll be coming out with some interesting results.
Yeah, there is a question from Kirti Chandra Sahu. What are the typical electric field potentials observed inside clouds and in the region below the clouds? Expecting that it is very high, how difficult to create these in the laboratory?
How difficult it is?
To create in the laboratory.
Oh, yes. You see, inside the cloud, you have, as I mentioned, that the largest electric field that have been observed so far is 3.4 kilovolts per centimeter per millimeter. But below the cloud, you have almost, I will say, one hundredth of that or 1,000th of that. Just what happens that as soon as cloud get electrified, they attract ions from the outer atmosphere. These ions enter into the cloud, and just because of their free path is small in presence of cloud droplets, they get attached to those droplets. So, and these droplets are charged. Once they are charged, they form a kind of conductor, and inside that there is a large electrical field and charges. So any charged body enclosed within a conductor doesn't have that, you can't sense it from outside. That is the main difficulty. And that's the reason why this remote sensing and there's measurements outside the clouds, they are not capable of detecting what is happening inside the, or what kind of electrical fields or electrical charges they are existing within the cloud. You have to enter the cloud. And once you enter the cloud, there are a lot of difficulties. Difficulties in this way that the whatever platform, balloon, aircraft, or rocket, whatever you introduce into the cloud, that body itself distorts the electric field. So for whatever objective you are introducing the platform, that parameter itself is distorted. So, and in addition to that, there are lots of electrical effects due to, as we have seen, emission of corona or water droplets colliding and producing electrical effects in that. So that's a really a big problem that has so far been not been solved. All, as I say, all kinds of platforms they have been used, and even aircrafts, even with the equipped with the 7 field mills at different positions of the aircraft, they have been tried to which not only measure the electric field, but also they, by mathematical formulation, they take account of the distortion of the electric field by the body, by the platform electric field. But so far, I don't think there is a satisfactory method of this thing, measuring this. But so what I was saying to answer your questions, that what exists outside the cloud is totally much different from what is inside the cloud. So outside the cloud, there are 2 orders or 3 orders of magnitude smaller than inside the cloud.
There is another question from Kirtisandra Saho. He's asking, how do you deal with suspending different size droplets in the wind tunnel?
No, we did not suspend the ice particles. It's an open-ended wind tunnel. It's at atmospheric pressure, and only thing we control is the temperature at constant level, not even sub-freezing temperature or temperature.
He's not asking about ice particle. He's asking about different size droplets.
Water. But just for your information, there are tunnels. Actually, you might have heard about the Okla tunnel at Professor and his colleagues. They did a lot of experiments in University of California at Los Angeles. And that wind tunnel became very famous, and they have a temperature, large refrigeration system, and very well controlled this thing. But they have, unfortunately, they have not gone into the study of studying the electrical effects on.
Yeah, there are 2 more questions.
Yeah, next question is from Arundhati Kundu. She asked how lightning associated with the drier environment that cause wildfires is different than typical lightning events of a thundercloud.
With lightning discharge associated with fires.
Yeah, how it is different than the typical lightning events of a thundercloud.
No, in thundercloud, there, as I said, charge separation takes place on account of charging mechanism proposed by different people, this thing. But in fire, I will say yes, not in fires, but I have heard a lot of lightning, intense lightning associated with the volcanoes. And in that, there are some mechanisms, but separation of electrical charges, that those mechanisms are not very well developed. There may be a lot of turbulent motions associated with these things. But if you are seeing the effect of fires, how do they affect the electrical nature, lightning nature of these things? Yes, they do, because they produce a lot of ions into the atmosphere and a lot of aerosols that can be introduced with convective motions associated with the fires into the cloud and this. So these things that have been observed to affect the lightning in clouds.
Okay.
There is one more question.
Yeah, one more question from Trisanu Bani. So the question is, what is the tentative electric field threshold of cloud to ground lightning? Whether it changes from place to place or content in the atmosphere?
As I said, at ground level, you require a very large electric field for electrical breakdown of the air, about 30 kilovolts per meter, per centimeter. And then, but as you go higher up and pressure reduces, This is about reduces to about 1/5 or 1/6 of this value. And once you have an advancement of charge cloud droplets and water drops with almost 100% relative humidity, it further this breakdown value further reduces. So I will say, but final value for breakdown also they have not been precisely predicted by due to this preparation. But and that's one source of very uncertainty, large uncertainty that we don't have exact values of what are the values required for breakdown of the air and in what. The only thing known is they are very large to trigger a lightning discharge, a streamer. But once that streamer is initiated, then streamers can propagate in one much weaker fields.
Sir,
there is another.
I want to tell you that Dr. M. Ravichandran, our secretary MOS, has also joined to say something with you. So I don't know whether Dr. Krishnan is there.
You are giving me more and more surprises.
Yeah, I am sorry, sir, but he has joined this.
No, I was listening. I was listening from YouTube, so I want to carefully listen. What after maybe a decade or so, I am just listening your talk. So I was very eager to listen. So I was listening from YouTube, and Tara told, "No, you join here," like that. So that's why.
We are so blessed today with so many nice people just from Kamra sir, and we are so thankful to you, sir, for joining. And Dr. Krishnan is also there. Yeah, sorry not having been invited you earlier, but Kamra sir is there. Please talk to him.
Dr. Ravichandran, it was good to see you. I'll say.
Yeah, definitely I will come and meet you, sir, next time when I come to Pune. Last time I couldn't meet you. So
yeah, I think I heard that you are very tight schedule and you had to go run back. So I will be very glad to see you. Thank you.
Thank you so much, sir. And we are actually Kamra sir is so inspiring for everyone. I am seeing that many people are writing about he is an inspiration, and I think we are very proud to have him in this series, and really fantastic. Thank you so much, and you all blessed us. Thank you.
Yeah, thank you, sir. Thank you, sir. Very inspiring. I missed the first part due to other meeting. I'm sorry. I'll watch the YouTube.
Professor Save Levin also joined. Actually, Kamra sir wanted to meet him earlier, and I invited Professor Levin also. So he also joined. It was such a pleasant surprise that all of you joined and gave him a very nice time. Thank you.
Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you. Yeah, there are some more questions to answer.
Yeah.
Sure.
There are two other questions.
Yeah.
So one question is from his past PhD student, Vimlesh Pant. So he asked, is there any difference in continental and marine clouds in terms of charging of droplets and how it changes as a function of temperature?
Oh, that's a good question. No main difference between continent and marine clouds is that of convection. Now, on the land surface, we have very high convection. Cape values are very high. In marine environment, also Cape values are very high, but convection is not so high. So that's adds one very major difficulty in quantifying the role of Cape in vertical growth of the clouds. But once that is given, one another difference in continent and marine clouds is that warm rain region, no, the region of cloud extending from freezing level downwards to this is quite high in marine clouds. And but in continent clouds, especially for example, if you take in northwest region of the India or in Pakistan area or this thing, the cloud bases are so high, about 3 kilometers, so sometimes, so that makes a lot of difference. The difference from electrical point of view is that water content that can be carried over to the mixed layer region is very high in this high water content clouds. If the cloud drop size is small and Cape values are high, and that is the region where electrification mechanisms they take place in mixed region. So, I mean, whether they are have ice phase or don't have ice phase, it depends a lot of depends on that. But one thing is sure that their nature of electrification with vertical development is much different. How much different? I think there are not many studies of electrical measurements over marine clouds in open seas. You must find some studies near to seacoast or this thing, but in open sea area, there are very few studies to say. But there are some reports, but basic parameters is development of clouds in vertical direction. It's much limited in marine environment. And that is, I think, from the right from the beginning of suggestion for global electric circuit, CTR Wilson and these people, they first they were considering that clouds over ocean, they may not be much contributory factor in global in GC, but later on they realized that precipitation coming out of those clouds, they can be very substantial. They can have very substantial contribution to this GC. So about the lightning nature, it's not, but only satellite observations, they say that lightning activity in marine clouds is very small, say about 1 order of magnitude less than the continent clouds.
Thank you, sir. There is one more question. Let us take one more question. Are you okay, sir, to go further?
Sure.
Yeah.
Yeah, there is another question from Sumit Kumar. Sir, how much?
Not Sumit Kumar.
No, there is a question from Sumit Kumar. So he
Okay.
asks, how much aerosol particle influence lightning?
Okay.
You bet. This. I will say this is the age of aerosols. So whether it's the climate or any other field, aerosols do affect the electrification. As I told in my lecture, that clouds developing over megacities or over this, industrial areas or oil refineries, they have much more lightning flash rate than over other regions. So reasons of importance may differ, but that is one observation. They may be affecting by increasing the nucleation rate in some clouds, or increasing the content of smaller particles that can be carried to much higher height to mixed region clouds, where they can contribute to larger electrification. Those can be factors in that, but they definitely have impact.
Yeah. One more question is there.
The last question is from Rupraj Bishwa Sharma. The question is, apart from the balloon and rocket observations, can drone be used to measure the electric field inside the cloud?
Yeah, they can be used, provided they are not thrown away. but even they will have limitation of having conducting bodies distorting the electric field, or sharp points very close to the sensors that can distort the electric field, or produce large amounts of ions, and same difficulties associated with an aircraft.
Definitely. Sir, I want to request you to say something to the young generation that is working on these fields, especially the atmospheric electric fields, cloud physics. Your advice to them, please, sir.
Well, I am also young, so
no, you are very young, but younger than you. Sorry.
But I will not hesitate to say a few words. That I think this area of atmospheric electricity scope in meteorological phenomena, that has not been taken for its value in importance of their importance. I'll just say at the beginning of the 20th century, if you might, or many of you might have known that Lord Faraday, Lord Kelvin, he got so impressed with the atmospheric observation that he made a statement that in future weather forecast will be made with an electrometer. So, although it is far from imagination, now I will not say far from imagination, because still they have what many people believe, that the significance we have given to thermodynamic parameters, say thousands of observatories around the world, And if you count the atmospheric electricity observatories, they are few. You can count on fingertips. So, knowledge of atmospheric electrical parameters, even at the time of, I think Dr. Ravichandran is there, at the time of this polar year, this thing, even in Antarctica, there are about 30 odd observatories which are taking meteorological observations. But electrical observations which on which stations they take is only 7 or 8, which is considered as a very ideal platform to take observations. So the limitation of our knowledge of electrical phenomena maybe one very big reason for that may be that we don't have enough knowledge of the space and time variations of these variables. So I will not go for a recommendation that we should increase electrical observations at the scale of this thermodynamics observatories, because until we establish something basic to show their importance, until that we can only say that these electrical forces, electrical effects have a lot of potential in not only in cloud physics phenomena, but in other phenomena. For example, something so long back I had experienced that occurrence of tornadoes. Now, such large velocities which occur in tornadoes, they are very hard to be explained by thermodynamic reasons. But at such a small scale, few meters at the most. But so we have to look for other regions. For example, there are observations in which these funnels of tornadoes have been observed to have been lighted up by lightning. So occurrence of lightning in those tornadoes is so intense that they are lighted. And then there was a small laboratory experiment that if you have a vortex generated by this in absence of lightning, and it has some length. But then if you generate lightning and surrounding that you generate a vortex, that vortex can be extended to say 1.5 times or 2 times, up to 2 times. So what is the reason for that? Is electrical heating of the tornado inside the body of the this thing is so small, so large that it can affect the terminal velocities to that extent. So there are regions in which
untouched regions of the science to explore.
Yeah, there are regions. So definitely, I will advocate not only because I'm a man of that country, but I will strongly advocate that research in this area should be needs some encouragement.
You have shown, sir, you have shown that the laboratory studies are so important, and it can be so useful for the modeling community as well. You have shown that from your research. You have shown that. And so we know, even now we know very little about the mixed phase processes in the cloud that are indeed very important for the extreme rainfall events. So we need to indeed study those things as well, right? So and also for the lightning processes that are very real.
We know very little about this extreme rainfall region or cloud burst which occurs, in which it is very difficult to explain such a rapid development of rain at such fast rates. So I will not say electrical things are responsible, but they are worth investigating. The factors, they have potential. They have been shown. When we find in laboratory experiments that collision coalescence can so much increase the electrical effects, then I think we should. Only thing I think I strongly feel that there are less emphasis given to this such interactions.
Thank
and
you.
saying that in front of the secretary of I think I'm aware of the dangers.
No, we are talking about the scientific aspects, and let us request our secretary, sir, and Dr. Krishnan to conclude.
I don't have anything to say other than that. Of course, I continue to any time I can listen Dr. Kamra. So I am very fortunate to have him my guide. And if he would have been not there, not only science or atmospheric electricity, but also the basic principles which I learned from him. So that is one of the reason I am here, if at all. I think he is a real good motivator.
This is all because of your labor and sincere work, very sincere.
Yes. And also, I think I know that it is nowadays not only that as the time passes, or the global warming scenario increasing or whatever the things, the importance of lightning also is become more and more. So I think we need to study, maybe I think we have to, not only lightning, it is maybe the airborne, maybe with fair weather electricity of airborne or anything, satellite or anything if we known, so that we can have a first clue what is the electric field magnitude in different places or time, space and time. If you know, then there may be a possibility to put how much is required in terms of space and time in various places. Of course, that is very important. As he rightly pointed out, we need to have some demonstrations. So whether how good the thermodynamical forces vis-a-vis the electrical forces. So what is the contribution of electrical forces in thermodynamics or in dynamical process, that need to be demonstrated. So that's good. But having said that, as for lightning or tornado or something like this, definitely electrical forces are playing a major role in the dynamical processes. So maybe both the electrical and the thermodynamical process contribute to the dynamics of the system. So I think the only thing is we need to quantify whether it is substantial or negligible. So that's what our objective we need to understand. So anyhow, that is a thing. I think maybe Tara and other group, they can work on it. I think Pawar also.
Actually, Dr. Pawar is also here.
Yeah. I think we have to work together. Work together in the sense. Okay, I am thermodynamics group. I will work separately. I am electrical group separately. Means nothing will converge. I think we need to work together to see that what is the collective mechanisms exist that we need to understand.
Yeah.
Absolutely. I agree with what Secretary said. Recently, ICER ICER Pune, they contacted, they are interested in working with IITM, especially the high altitude lab, on this lightning connection between lightning and heavy precipitation. So maybe maybe we can discuss this sometime.
That type of things we need to encourage. I think more ICER or IIT, we need to give some people to new things. Yes, maybe heavy precipitation is occurring. Is there any role to play? So just a question, yes or no, that itself is a big thing. If it is no, then we can go to other own direction. If it is yes, then we can more investigation we can put forth like that.
Definitely. Thank you all, and
thank you, sir. Thank you very much.
Thank you so much, sir.
Thank you, sir. Thank you, sir. Thank you, Tara, for arranging this.
Thank you, Tara.
we are in a continuing process, sir. We will invite different speakers.
Yes.
And I am getting response from students and all. They are really benefited by. So thank you so much for joining. This is a real
thanks a lot.
Nice gift for all of us, and actually honoring our Kamra sir, and we really appreciate it. Thank you.
It is a nice joke also this time. Corona, what sir mentioned.
Yeah. That is a different.
I thought twice while writing that, and I consulted whether the spelling is the same.
Thank you, sir. Then shall we then conclude? I also want to thank all others who have helped. There are a number of people here. S.D. Pawar sir, Mahen, and Sachin Deshpande. They all indeed helped to make it possible today. And Padmakar from the computer division. Thank you so much.
Thank you.
Thank you.
Thank you, Dr. Krishnan. Thank you, sir. Thank you, sir. Now we will talk soon. Thank you, sir. Kamra, sir.
Thank you.
Thank you.